Okay, so now let's drill down and look at the specific theory and method developed by Matt Jockers, who is going to be the focus, pretty much the focus of this module, because what he's done is taken sentiment analysis that we talked about in the last module and used it as a foundational approach for the study of narrative. So Matt developed a software package and a method for studying narrative computationally called Syuzhet, and we'll look at what that means in a second. That's actually a Russian word that comes from Russian formalist theories of narrative. It's written in R, and in fact I have a notebook that uses his R package in a Jupyter notebook that you're free to look at, and I've adapted some of it as well into Python. So Matt's a professor of English and data analytics at Washington State University. He used to be at Stanford and the University of Nebraska as well. He's been in this field for a while, and a very interesting fella, a great blog to follow, and he's got a couple of books out that are super important as well. So again, he applies sentiment analysis to the study of narrative with the assumption that fluctuations in sentiment are proxies for fluctuations in plot movement. So we can put this under the category of hypotheses, such as we've talked about already in this class. The statistical semantic hypothesis, for example, the distributional hypothesis. This is another where we're saying, plot, which is about human action, and as I've described it as a theory of human action, which relates to concepts of destiny, can be inferred from a novel or a story by looking at emotions, which are in a sense responses to the world and are associated also with motivations for human action. So we're not going to go into a lot of detail about the theory of what the relationship between emotions are and destiny, but you can sort of right off get a sense of how they're connected. So the word Syuzhet comes from the Russian formalists Viktor Shklovsky and Vladimir Prop. We don't need to read them. Prop, of course, is very famous for his theory of the folktale as a sequence of functions. If you ever get a chance and check out his book written in the early 20th century called The Morphology of the Folktale, you'll be really super impressed about how modern that is as a branch of text analytics, really, or a first foray into text analytics. They both argue that narrative has two parts, fabula and Syuzhet. So fabula basically consists of the elements of a story. You can think of fabula as the set of actual events that take place that you're trying to represent existing in chronological or historical order. And Syuzhet is the manner in which you tell the story. You have a lot of liberty. You don't have to tell a story in the order in which the events take place. You can, show something first that happened later, and then tell the story that leads up to it, and so forth. So Syuzhet is sometimes called plot order, and those of us who watch film, are probably quite familiar with a lot of variations on this. And here we're going to look at one. This is a diagram showing probably the most extreme case of the distinction between Syuzhet and fabula. The order in which a story is told and the order in which the story takes place. So if you look at this example here of the movie Memento, I don't know if you've all seen the movie Memento. I don't want to give it away, but it's basically a movie that's told in reverse chronological order. And this is a diagram that shows the distinction between those two sequences. So and also it's very interesting because the movie makes a distinction between the color sequences and black and white sequences to distinguish between the present and the past, and you can see they eventually converge at the end. But if you just unpack this diagram, won't go too much detail into this, you'll see that the little narrative sequences that are in red begin at the end of the story, and they work their way back to the beginning of the story. Okay, so what he's doing with sentiment is something like this. So the basic idea is to show, and you can see the choppy graph is the sentiment that you generate. And we looked at some sentiment last time over narrative time, and to try to translate that into the smooth blue line, which is what we're going to think of as the plot trajectory in the manner that Vonnegut talked about it. So we're trying to get from the rough line, if you will, to the smooth line in this work. And this you can see, let me go back here. We're talking about The Portrait of the Artist as a Young Man, which is a novel by James Joyce. And here, this is a diagram from Jockers that actually his students made in a class where they started to annotate the ups and downs in the story. And the point here is to point out that, in fact, the sentiment trajectory that the sentiment analysis tool that he uses provides does, in fact, correspond to points in the story that map onto those sentiments, right? That's really what this whole exercise was about. So you have this kind of trajectory of the sentiments in the story, and our goal is then to create that smooth line. So here's another example. A picture of Dorian Gray has this sentimental pattern, this set of sentiment signals, if you will, throughout the text, and then the blue line is what he wants to show as the smoothed version of it that represents the narrative arc in Vonnegut's sense. Here we have the Da Vinci Code. And by the way, I should be mentioning that at the bottom of these are summaries provided by Jockers about the nature of those particular narratives. So this kind of narrative arc, can be summarized as Dorian's life takes a dark turn as the reality of the portrait becomes apparent. So you see it's kind of smooth, up here, kind of high, and then it goes down. Story ends on a low note. Here, Dan Brown never lets the plot become too troubled or too much of a downer. He baits us and teases us with fluctuating emotion. And then we have Blood Meridian, which is a really dark novel. I don't know if you guys have ever read that, but you can see that it starts off pretty low and it just gets worse. Blood Meridian is a dark book, and the more generalized blue trend line lingers in the realms of negative emotion throughout the text. It is a very different book from the Da Vinci Code. Indeed, it is. So the hypothesis and questions here. So given that fluctuations in sentiment are a proxy for fluctuations in plot movement, and that there are a finite number of plots in the world, and this is drawing from prior sort of domain knowledge, literary theorists estimate that the number of plots in the world, possible plots that you can tell, range from 3 to 36. And I cite some authors here that you don't have to really look at, but just to know that there's a lot of work on this. What Matt wants to do is take this this research a little bit further and actually develop an empirical model for plots. Like, what can we learn using sentiment analysis from a corpus of novels to actually infer how many plots there are in the world, and come to some more precise conclusion than what these people have come up with based on their pre-data scientific methods. So what Jockers does is he collected 41,383 novels, generated plots for all of them in the manner that we've seen, the sort of rough fluctuation of sentiments, normalized them so they can all be compared, and then came up with a set of foundation shapes, which then become your plots that you can see as having a greater or smaller number. So one of the initial problems that faced by Jockers' method is dealing with the problem of text length when comparing novels. So one of the axes of variation, if you will, dimensions of variation for novels or stories is length. You can go everywhere from Heart of Darkness to Clarissa, to take two extremes of novel length, for example. It's not immediately obvious how to deal with this. I mean, you could do things like chunk them all into units of 100, but if you do that, the chunks are going to be larger in the larger novels. And then you have this problem of washout, because we know that the larger a length of text, the more likely the sentiment polarity is going to become zero, because you just have much more chance of the polarity balancing out in a larger unit. So you need to have a proper way of doing this. Without really going into too much of the justification or the rationale for this, what Jockers decides on using is something called Fourier transforms to achieve this normalization. So a Fourier transform is a method derived from signal processing that decomposes signals into component waveforms. When you do Fourier transforms, you can say that you're transforming the time domain into what's called a frequency domain. I'll show what that means in a second, looking at it visually. And once you do this, once you transform the domain from one to the other, you can actually remove unwanted waves that basically function as noise and achieve a much cleaner signal in the time domain when you map it back to the time domain. And this provides a way of transforming the sentiment-based plot trajectories into a form that's independent of story length. So let's look at how that actually works. Here's a simple way of thinking about a Fourier transform. So what a Fourier transform does is take a complex signal such as we have on the left, and this is, in nature, you find lots of signals like this. They could be coming from lots of different sources. And what you can do is determine that signal is actually the composition of a bunch of elementary waves. And in fact, you can just break it down into a composition of a series of elementary waves that are defined by successive reductions in the frequency. So you can have a frequency that is, 1/2 hertz, plus how much of a frequency of 1/3 hertz, plus how much of a frequency of 1/4 hertz, and so forth. And with all of with this series, worked out to some arbitrary, number, you can recompose the original signal as a composition of those elementary waves. It's a really cool method that you can use. Now, the thing about it is once you break your signal, your composite signal, into these component signals, then you're free to get rid of some of them. Oftentimes that's used to get rid of hiss in audio signal processing. But in our case, what we want to do is get rid of, you can think of it as noise or hiss. We want to get rid of some of that fuzziness and that roughness of our emotion signal, if you will, and come up with something smooth that looks like what we're going to call the foundation shape of narrative. And so what Syuzhet does is apply Fourier transform analysis to the signal that we've looked at of emotions through the novel, or polarity, and it just picks all but the lowest terms of the Fourier transform and returns that back and then maps it, and you end up with this very smooth looking narrative plot. So here's some examples of what Jockers calls foundation shapes. So once you do this, you end up with nice graphs of this kind. So here's one, the foundation shape of Oscar Wilde's Dorian Gray. It goes up and it goes down and comes back again. Here we have one of James Joyce's Portrait of the Artist as a Young Man. So you can see that this kind of signal or waveform is much more, it lends itself much more to serving as a representation of the plot trajectory of a story, as opposed to the more messy signals that we saw earlier. So given this premise, here's the process. Generate plot shapes from all the books in the corpus, so that very large corpus we talked about. And once you generate these very basic plot shapes of the kind I just showed you, they're essentially vectors, so you can generate a similarity matrix over all novels using Euclidean distance, and then cluster them using hierarchical agglomerative clustering. And once you've clustered them all based on this very simple description of their plot, you can then get to the question of figuring out how many basic kinds of plots are there. You can do cluster identification and come up with some description of fundamental plot shapes. So we end up with something like this. In his analysis, we end up with two very broad plot types. One is man in a hole, and the other one is man on a hill. And then these break down into subordinate types that then can be used to classify other kinds of novels. So here's what Man in the Hole looks like. It's story starts off good, and then it goes bad, but it gets good again. Man on a Hill is more like story starts off neutral or bad and gets good and then gets bad again. These are what Jockers has determined, based on the analysis that we just described, to be the two major foundation shapes of all stories. Very interesting thesis, and one that's actually consistent with what Vonnegut was describing in his rough sketch of this concept of shape of stories. It's worth pointing out that, as the dendritic graph showed, each one of these major groups has a bunch of subgroups. Here we're just drilling down one level into man in the hole types. So you have a man in the hole type 1, a man in the hole type 2. You have the same with man on a hill, type 1 and type 2. And this actually decomposes into further subtypes, as we saw, if you remember what the dendritic graph looked like. And let me just quickly go back there and show you. So you can see that the graph actually has some depth here. We could cut it off arbitrarily and decide that we've got enough at some point, but it gets pretty finely broken down, as you can see. So let's go back here. So what I'm going to do now is I've asked you to read an interesting sort of narrative, if you will, a story of the fate of this idea and this thesis that Jockers came up with. So he publishes on his blog his work in this area. He publishes in GitHub the code base for doing the research and so forth. And what happened was something quite interesting. So just this is how the internet is supposed to work for scholarship, right? He puts it out there and people immediately respond. And there were some very interesting responses to this when it came out within the digital humanities community. And I'm going to point out just one of them. This is from a woman, Annie Swafford, who at the time was at UVA, English graduate student. And she did something very interesting. She, a lot of people in this field are very skeptical. You show them something like this, and it looks nice, but they're going to push on it, kick the tires, and figure out whether it actually makes sense or not. And she pointed out some things that are really quite interesting. So the first two are kind of, a lot of people have these issues with sentiment analysis. The fact that sentence parsing is not perfect. It's not always correct, so your unit of analysis may be flawed, and there's an example I'll show you in a second. The second is sentiment attribution, and we saw that in our last module, that what looks like a negative or positive sentiment evaluation of a sentence or another bag of words turns out not to be consistent with what we might think to be intuitively looking at, and this is the case here as well. But most importantly, we're going to get into this problem that she points out regarding the foundation shapes, and that is the fact that some of these foundation shapes can be attributed to what are called ringing effects or ringing artifacts of the low-pass filters. This is purely an artifact of the algorithm, and some of the things that we think look like the story turn out to be not related to the story at all. And that's an interesting problem and something that we're going to have to address if we want to go forward with this kind of research. So here's an example of a sentence parsing problem. Don't want to necessarily read this out, but just to point out to you that this is an example from Charles Dickens, and it just shows you how complex sometimes it is, especially with literature, to parse what looks like a sentence into constituent parts, or what looks like a paragraph into constituent parts. This is, you have sentences within sentences here, and it's all part of one sentence. What do you do with this? There's a lot of this kind of text in a writer like Dickens, and so it's not a trivial problem. But we're not going to really dwell on this so much. Here's another set of problems that we can all, pretty much obviously see that sort of is a problem with sentiment analysis and attribution. The first thing that she points out is that, sentiment analysis looks at individual words. You have things like Vader that look at sentences and look at heuristics, but essentially they're not doing, relatively what might seem to be easy things like looking at modifiers like adjectives or negations or things like that. Those seem to be really important in assessing whether a sentence has a certain polarity or not. The other problem is polysemy, in other words, the fact that words have multiple meanings. That seems like a really obvious one. Another problem is that in this particular analysis, Jockers is using some contemporary English dictionaries or lexicons and applying it to an older corpus from the 19th century. Things like repetition are discounted, like the fact that a word may be repeated many times. It seems that in some contexts, when a word is repeated, it does mean that it's more significant in the case of sentiment. And we tend to downgrade those with certain kinds of bag of word models of representation. Sometimes we logarithmically smooth out repetition and so forth. And finally, she just points out the lack of nuance in these lexicons or this lexical method as applied to texts of the kind we're looking at. She gives an example here. Just check out this passage real quick. I haven't been sad in a long time. I am extremely happy today. It's a good day, but suddenly I'm only a bit happy. Then I'm not happy at all. In fact, I am now the least happy person on the planet. There is no happiness left in me. Wait, it's returned. I don't feel better. I don't feel so bad after all. So here's a passage from somebody who's clearly going through some emotional difficulties, maybe bipolar, we don't know, or maybe depressed and going through some cycles. But because of the frequent use of the word happy, The graph on the right shows the sentiment polarity attributed to this passage, and it's attributed to be extremely happy, and that's just because the word happy is used all the time. And this is a problem, obviously, right? If you're going to, what if a novel is written in this way, in which people are basically writing about the fact that they're not happy and using the word happy all the time? This is a problem that besets the method that Jockers is using. There are methods to overcome this, to be more effective in overcoming this now, using machine learning, for example, or more sophisticated uses of lexicons in combination with grammatical dependencies. But that's not the case here. So it's a real problem that she points out. But here's a more serious problem, and one that we're going to drill down on, which is that when you apply a low-pass filter of the kind that Jockers applies, which is when you do a Fourier transform and then you start eliminating the lower waveforms, you end up with what are called ringing artifacts. You end up with extra humps in your graph that are not really present in the original graph. You end up with something on the right given something on the left. And that's a problem. And it actually arises more frequently. It becomes more of an issue when you have fewer sinusoids on the left. It's an interesting sort of paradox, and we'll look at what that means in more detail here. So here's an example where she really shows how this can be a problem. What she does is she says, okay, let's look at what these foundation shapes look like, what the Fourier transform analysis ends up producing if we mess with some of the signal data in an obvious way. So let's take this emotion data and let's take out the last third of it, for example. What kind of foundation graph do we end up with then? And she points out you end up with the exact same thing, which is an interesting problem. Or in a more extreme case, here she only preserves the 20 middle sentences of the novel, and look what happens. You still end up with the same foundation plot, which it's got to be registered as a problem for this particular method. And here's something, LePage's quartet, which basically just shows how different signals can really produce the same foundation shape. So each one of these that you're seeing, the underlying signal, which looks quite different, actually produces the same foundation shape. And you have to ask yourself, is this a good thing? Are these things really fundamentally similar in this respect? Or is it just simply a matter of the fact that we have these ringing artifacts that emerge? And she also points out that you can get different. So here we have the same foundation shape with respect to what appear to be, different underlying sentiment signals. Here we have the opposite case, which is it looks like we have similar underlying sentiment signals that have just been tweaked in a slight way, nearly invisible low frequency changes, and we end up with different foundation shapes. This is a quite interesting experiment, which really makes you wonder whether it's valid, whether the method Jockers is using is valid or not. And finally, we look at Ben Schmidt, and there are other criticisms as well that we're not going into in this video, which I encourage you to delve into in the blog sequence that I gave you. But here's a really good case where Ben Schmidt really points out the major problem, and that is that if you're using the Fourier transform system or approach, it makes an assumption about narrative. It imposes that assumption on narrative. And it basically argues that the beginning of a story has to align with the end of a story. And so here he presents a real case of, really simple kind of emotional trajectory, which is that you just have a linear increase, with a slope of 1, essentially. And look at the Fourier transform's result. You end up with a story that goes down and then goes up, but it comes back down again. So it begins and ends in the same place, and that's clearly not what's happening with the data, right? The data is just a steady increase in sentiment. So there's a real problem, and what that means is that it's probably a good idea for Jockers to replace the smoothing function he's chosen, the Fourier transform, with something else like low S or moving averages.